All right. So 7.2, we are talking about parallelograms here. Okay, talking about parallelograms, which are a special type of polygon. We dealt with all the polygons on Monday. Now we're looking just at parallelograms. Tell the person next to what a parallelogram is, or somebody around you.
It's like a parallel. All sides are parallel. Not necessarily
The parallel
yeah,
is
the rectangle, like all sides
the
are parallel.
quadrilateral.
Could be a
Both pairs of opposite
that quadrilateral, when both pairs of opposite sides are parallel.
All right, here we go. Here we go. So we see the definition here, right? It is a quadrilateral, so there are four sides and only four sides. Both pairs of opposite sides parallel. So two pairs of parallel sides gives us a parallelogram. This is the type of parallelogram we are going to deal with today. Rectangles are also parallelograms, squares, rhombuses, right? But we're going to deal with those special cases, those special parallelograms after the quiz. Today we're just going to talk about our general form, our general parallelogram.
Would you call that a normal parallelogram?
Sure. Why not? A couple things to point out in terms of naming it. When we name it, we use that parallelogram symbol, just like we use the triangle symbol. When we call something triangle ABC, we use that parallelogram. That keeps us from having to write out the word parallelogram.
Is it
So
a rectangle? Or
it's not a rectangle, it's slanted slightly. Yep. So parallelogram, PQRS. And then when we name it with the points, we're using all the points, all 4 points, and you have to name them in order around the figure. Okay, it doesn't matter what you start with, it doesn't matter which way, which direction you go. Most of the time we'll go alphabetical, but we don't have to. So like we could call this parallelogram RSPQ, completely okay. As long as you're going around the figure. You cannot jump through the figure. You cannot name it PRSQ. Okay, you can't go through the figure when you're naming it. It has to go around. And what that does is that helps us, and we'll see that later on in one of our problems, helps us to understand where these points are located in relation to each other. Because if we see that name, I know it's got to connect P to Q to R to S back to P. Okay, just based on the name. All right. So this is the definition of a parallelogram. Okay, this is the definition. We're going to see 4 other properties in our theorems, but this is the definition. Okay, and that's important because we are seeing proofs again. So when you want to say the reason why we have parallel sides, it's because of the definition. Okay, definition of parallelogram. All right, so let's look at our 4 theorems here. First couple are very straightforward. We have parallelogram opposite sides theorem. Just tells us if quadrilateral is a parallelogram, then the opposite sides are congruent. Okay, opposite sides are congruent. You'll notice all 4 theorems today start the same way. If a quadrilateral is a parallelogram, then something, right? So that's the hypothesis for all of these is going to be the same. Okay. Tomorrow we'll come back and we'll do the converses. So we'll take a look at that tomorrow. Those are the 4 things you got to copy down tonight for tomorrow. All right, but for today, the hypotheses are all the same. All right, so opposite sides are congruent. And then our second one, opposite angles are congruent. Right, opposite angles also congruent here. So R and P, Q and S, congruent to each other. So we know that every single time, any parallelogram that we have, as long as we know it's a parallelogram, right? So that means they're either telling us it's a parallelogram in words, or they show us that we have 2 pairs of parallel sides by giving us the arrows, right? But we have to know it's a parallelogram first, then we can apply these theorems. Any questions on those 2?
Is the only way to identify a parallelogram is if the 2 opposite pairs of sides are parallel, or
For now, tomorrow we'll get other ways of proving that it's parallelogram. That's what the converses are going to be, are proving that those are parallel. Yeah. All right, so we're going to look at those theorems in terms of a problem like this as a very, very basic version of the problems. Talk to the person next to you, what is X, what is Y?
Why 65?
All right, so of course Y is 65, X is
8.
8. All right, I don't know where 135 is.
Oh, I did the other angle.
Oh, okay. No, we're just looking congruent, right? So it's 65. Okay, good. So we might see harder versions of that, right? Where it's not just x plus 4, but it's 2x plus 10, and the other side is 5x, right? We just know we're setting them equal, solve for x. Plug it back in if we need to. All right, our other two that we have, a little bit harder, a little bit more involved, maybe a little less common sense. But here's our third one. Parallelogram consecutive angles theorem. Consecutive angles. Consecutive, remember, are two angles that are next to each other, two in a row, would be considered consecutive. And what we're saying here is that any two consecutive angles are supplementary. They're going to add up to 180, guaranteed. The reason behind that, and you see it up above, that's why I showed that up there too, is because they're basically just CIA. They're consecutive interior angles. Because we know we've got parallel lines in this parallelogram, right? I've got parallel lines cut by a transversal. That's CIA, right? Those are consecutive interior. We know back from chapter whatever it was, 3, that those are supplementary. And you can do that with any pair of these because you've got parallel lines all over the place. So any two consecutive angles are going to be supplementary. That means when you combine that with our second theorem about the opposite angles being congruent, then any two angles that you pick out, they're either congruent or they're supplementary. So again, it goes back to, do I know how to set up that equation? Am I going to set them equal? Am I going to add them up, set them equal to 180? That's all we got to pay attention to. Okay? They're either supplementary or they're congruent. Okay, questions on that one? Consecutive angles? All right, and then our last theorem here talks about the diagonals. Remember, diagonals go through the figure. They connect non-consecutive vertices. And what we can say about the diagonals is the diagonals bisect each other. Okay, they bisect each other, meaning that they cut each other in half. It does not mean that the diagonals themselves are congruent, right? I mean, you look at that, QS is not congruent to PR. Okay, we can see that. That's not true. So what we can say is that QM and SM are congruent, PM and RM are congruent.
And that gives you the midpoint. Okay.
So yeah, it would be the midpoint is where they are crossing. Yeah. Yep, the midpoint of both of them. And that would be the same. Yeah. It depends on the wording that they would give you, right? If they told you that M is the midpoint, then we could use definition to say the two sides are congruent. But if they told you that this is a parallelogram, then you would have to use this theorem to say that M is the midpoint. Yeah. Any other questions on parallelogram diagonals? Same sort of thing. We can set up algebra problems, right? If they tell us this is 3x plus 10 and this is 2x plus 20, set them equal to each other, solve for x, you know, plug it back in if we need to. We can still do those sorts of things. All right, I want you to recap those 4 with somebody, please.
So.
Parallel opposite sides theorem states that opposite sides are congruent.
So, yes, opposite sides.
And then parallel opposite angles theorem states that opposite angles are congruent.
Opposite angles theorem is, like, across from each other, they're congruent. And the, oh yeah, and then the consecutive angles, so they're separate.
Yeah. And then parallel diagonal theorem states that if a quadrilateral is diagonal
Wait, do they
bisects
cut them in half if you go from, you just go from one point to the vertex to the other? Cut them in half.
We got one now.
The parallel. If you just did one, you just did one
Vertical line,
one diagonal.
diagonal. Yeah, I mean, it's gonna create two congruent triangles. Yeah, it's not a reflection, but the triangles are congruent. Yeah. All right, moving on. Told you we were gonna have proofs today. Here's proof, we're looking at the bottom. Looking at the bottom here. Why don't you go ahead and take a few minutes. Write out this proof. Okay, I want you to practice writing it down, make sure we got the steps, everything like that. Take a couple minutes on it. You can do it on your own, you can talk to somebody if you need to. Why don't you talk to each other about it? Okay, see what they did, see what you're thinking.
What I did first is I did
Yeah. So, which one would that be?
and then so I did the given
That's good.
and then
Opposite angles.
I did vertical angle
I do that couple of like parallelogram, opposite angles.
I did angle B plus angle D. I know see why they're not doing. And then I did angle. I feel like it was 100 instead of 30.
So vertical angles for
I said the dot circle, I call it PO.
Yeah, so, and see the turn.
Parallel opposite angle. Angle B equals angle F equals substitution.
And then opposite sides.
But there's. Oh, I thought it was both, but the congruence on both.
No, that whole thing is.
Um,
All right, here we go. So we've got our given, that they are parallelograms. What can we say now? Kim, say it again.
Angle ABC is congruent to GBE
Okay, what's the reason?
because of vertical angles.
Okay, good. And thank you for naming them correctly. We have to use 3 letters there. Okay, we cannot say angle D and angle D. There are 4 different angle Ds there. Okay, so we got to be specific. So ADC, GDE, vertical angles. And since we don't have a congruency statement, we're not proving 2 figures congruent, we don't have to worry about the order in which we're naming them. Right? As long as the vertex is in the middle, then we're okay. You could name it CDA, that's fine. Okay. So we got vertical angles. What else can we say here? What else? Go.
That angle B is congruent to angle ABC, and then angle F is congruent to G. Because of the opposite parallelogram opposite angle.
Good. Parallelogram opposite angles theorem. And please abbreviate. Don't write that whole thing out. Yeah, so parallelogram opposite angles, because they're parallelograms, I know these 2 have to be congruent. I know these 2 have to be congruent. So we've got that. Okay. What's our last one here, Randy?
Transitive POC.
Transitive property.
Oh, transitive.
Yeah,
Because
transitive
Eagles-
property. We follow the train, right? We got B is congruent to ADC, ADC is congruent to GDE, GDE is congruent to F. That means B is congruent to F. Transitive property. And it has to be transitive, it cannot be substitution, because substitution is only with equal signs. Substitution is a property of equality with equal signs. Transitive is property of congruence. All right. Good deal. Questions on that? All right, those are the types of questions that you're going to see. It's going to be a lot of that, where it's transitive, it's parallelogram opposite angles theorem, sort of stuff. We got 2 more problems to look at, then we're done.
So in this unit, we're not really going to be proving parallelograms.
No. Nope. We're going to be proving angles congruent, sides congruent, that kind of stuff. Yep. All right, so the last 2 that we got to look at both deal with the coordinate plane. Okay, so we're looking at graphs, at points on graphs. Our first one here, we want to find the coordinates of the intersection of the diagonals of this figure. Now this one, we do not have to graph this one to be able to solve it. I want you to think about it. We want the intersection of the diagonals. How can I find the point where the diagonals intersect with each other? Brendan? Yeah, find the midpoint of one of the diagonals, right? We said that at the start. That where those diagonals cross, that is the midpoint of both of them. And I don't have to find both of them, I just need to find one. So if I can find the midpoint of one of the diagonals, then I've got it. The question then becomes, how do I know where my diagonal is? Right? Which ones are my diagonals between these 4 points? Yeah.
The order of the original statement.
Yeah, right. And this is that type of problem where that comes in handy. It helps us. Because I know this is named around the figure, my diagonals have to be LN and MO. Okay, LN and MO are my diagonals. I can tell just by looking at the name. So choose either L and N or M and O and find that midpoint. Okay, I want you to take a second, find that midpoint, please. Average of the X's, average of the Y's. Again, either L and N or M and O. You're doing it like every other. Okay, what's our midpoint going to be? What's our intersection going to be? Fran?
3.5 and 2.
Yeah, 3.5, count 2. Personally, I would use the zeros, right? Zeros and 7/4, so really we're just cutting these 2.5, so 3.5, count 2 for that. So if that makes sense to you, great, use that, do it that way. If you need to sketch it out to visualize it, do that, right? Whatever you need to do to be successful. Questions on that one? Okay, we got one more. This was a little harder to do in your head, so my suggestion is going to be to sketch it out. Okay, they give you 3 vertices. They want you to find the 4th one. Okay, so I want you to sketch it out. I want you to draw it out. Okay, doesn't have to be perfect, but I want you to sketch it out so you can visualize what you're looking at. Sketch out those 3 points. We want to find the 4th one. Finding that 4th vertex shouldn't just be, yeah, this kind of looks like it, right? There should be some sort of math behind it as to why that is your point. Talk to somebody about it. What are you going to do?
So what I did was I sketched it out and then I found the distance formula and found W to X
Probably a little longer than
to
what we show,
right.
but it does work. Yeah.
Or not, I didn't use distance formula, so I just looked at the X's.
Well, I
And
kind of
I looked at how many from
what I was
W
thinking,
to
like,
X and it was
if
minus.
you look at the difference between
So then
X
the
and
other point
W,
would be
and then you look at,
Z
and then you just like do that same,
from Z to Y, it would be
do that
minus
to
2, so
the
X would
coordinate
have
Z.
then minus 2 from that.
All right, so we know point Y has got to be up here somewhere, right? How are we going to find where exactly that point is going to be? Go.
So since point, point Z is 1 below point W, so then point, or Y has to be below X, so it would be 1 for Y-intercept. And then I did, when point W is 2 on the X part, or on the X axis, it's 2 away from X, and then 2 away from Z would be 2.
Okay. So you said it's down 1 here, so it's got to be down 1 here. It's over 2 here, so it's got to be over 2 here, right? Okay. That works. Can we do both of those from the same point though? Right? Kind of think of it more of a slope sort of thing. Where from W to Z is down 1, but then this way is over 5. And then I can go from here down 1 over 5 to get that point. Right? So if we think of it as slope, because we know that the opposite sides have to be parallel, and parallel means the same slope, that's going to help us to get that point. Right? Down 1 over 5, down 1 over 5, we get that point. Or you can look at W to X. All right, this is going up 5 backwards 2. This is going up 5 backwards 2. I think it ends up being here. I think it's 2, 1, right? 2, 1. Okay. There are other ways to find it. All right, I've had multiple people today said they found the midpoint of XZ and then went up and over here, up and over here. That works, right? That works because we know that has to be bisected. It's probably a little quicker just to do the slope from the sides. Okay. Any questions about 7.2? Like I said, tomorrow we're going backwards on it. We are looking at the converses in 7.3.